back to our channel, The Classroom. Today I'm back with a chapter of chemistry, as you can see written on the board, that is the Language of Chemistry. This chapter is there in class 9. And yes, one more thing, I've thought of giving you a suggestion, that is those who are belonging from the CBSE board or rather are studying in the CBSE board, I would like to say whichever book you are using, it can be a concise or maybe some other book recommended by your school or your teacher. If you follow the simplified chemistry book that is basically used in ICSE, okay, that is particularly of the Dalal series, so I think it will be much of benefit, because the explanation that is there, the number of examples that is there, okay, the unit test papers that are provided in this book is really very good, okay, for you to practice. So it's just a suggestion that even if you're having your school book, if you can refer this book for your study purpose, that is for all the details and everything, maybe one particular point is mentioned, if you are going into further more details of it, so it's better, suppose you're going for some reason why type of questions, so it's better to study from that particular book, that is simplified chemistry, okay, of the Dalal series. You can ask for 9 and 10, both are available, and other than that you can follow your own textbook that is provided from your school. That is obviously the main part. Anyway, now coming back to our chapter, the Language of Chemistry. You might be wondering what I have drawn over here. I'll be coming to this part, but before that, it is all about like chemistry. Okay, what is balancing of equations? How do we symbolize each elements? And how do we write these compounds? Okay, so here are we going to discuss about it. I hope this class will be very interesting. And the first thing that I'm going to come to is about the symbol. Okay, how do we symbolize each elements? You can see I have drawn over here some of the particular shapes. Okay, these are not shapes, these are some of the elements which were like figurative. These are the figurative symbol of some of the elements which was done in the earlier times. Okay, I'll come to this. Now, symbol is a representation of an element. Okay, it is how you represent an element. Now, as soon as you represent, suppose there is a particular element, you represented it in a particular way, there will be some few more elements, so that means each of these elements will have different type of symbols. Okay, so that is what is symbol, and what is the need of the symbols, so that we can demarcate or distinguish between different elements. This is a particular thought that came in the scientist's mind. Okay, the first thing that came in John Dalton's discovery or his thought was, why not naming the elements in these figurative symbols or in these molecular representation. These are one of the compounds, and ammonia is NH3, hydrogen sulfide is H2S, sulfur dioxide is SO2. So he thought of arranging or giving these like elements, these type of particular symbols or representations. Okay, but as he was going higher up in the studies, there are more number of elements which were discovered. He saw that this particular thing is getting difficult. Okay, how many symbols will he give? Okay, so that was becoming difficult and rather very impossible to remember, and especially the structures was so big and complicated. Okay, so what he did was making all these symbols and representation. Suddenly then Berzelius said, he was another scientist, he said that we will symbolize the elements according to their namings. That is, I'll come to this. Before that, I think I have already told you, you can see the symbols, these are just for you to know, okay, not for your exam purpose. That's what I'm telling you, okay? These are something which you should know, not for your exam purpose. These are not important for your exam purpose, but you should know about chemistry, all these things. Who gave this two things? This was given by John Dalton. Okay, he was a very famous scientist, as you know. Now, next, coming to the part which I said, that what did Berzelius say? Now, what did Berzelius say? That I will come to it. I'm rubbing off this part. Berzelius said that he is going to give the first letter of the name of the element as the symbol. Okay, like suppose hydrogen. Hydrogen, its name given was H. Why? Because it starts with H. Right? Carbon, C-A-R-B-O-N. C, because its name starts with C. Next, nitrogen. Its name starts with N, so nitrogen, N. These are the how Berzelius did the symbols of these elements. Okay, just by taking their name and taking the first letter of their name. That was how he was naming the elements. After some of the naming the elements, he saw that some of the elements which started with C, suppose calcium, also starts with C, right? But we have already by then named the compound carbon as C. So he thought of taking the first two letters of the name of the particular element. Suppose for calcium he named as Ca. Okay? He took Ni. Okay? There are so many such elements like this. Okay? I'm not coming to it right now. You can go through the book. You will find so many of them with the first two letters. Okay? Then, lastly, he saw there are some more to it where, which I was saying. Suppose CO, cobalt. It was given the name CO. Why? Because it starts with CO. Okay? Nickel, Ni. Calcium, Ca. Later on, he again saw there was another element discovered which was known as copper, right? But here, copper CO was already given to the name cobalt. That is, CO was already given for the name cobalt. Okay, so what to do with copper now? Will we be writing COP over there? It is becoming, day by day, it is becoming long. So he took the Latin name of copper. Latin name. Now, what is a Latin name? The Latin name of copper is cuprum. Okay? So, as he took the Latin name, that is cuprum, so from here, what he did was, he took the name as of copper as Cu. Let me write the C capital here, Cu. Okay? This was the particular theory or formula of the symbols which he gave. Then there are many other elements whose name are given after the Latin names. Like for example, iron. It's under the name of ferrum. We write as Fe. Okay? Gold. We write as aurum. That is Au. Okay? So there are many other elements. You will get that in your book. I'm not going into details now. With these, there will be hardly of 8 to 9 elements which are basically named after the Latin names. Okay, you should study those along with the name Latin names and be very careful with the spellings. Now, coming to the next part. Now, next part we come with valency. Now, what is valency here? Valency is the number of hydrogen atoms which can, rather you can say, combine or displace one atom of the element or radical to form a compound. Okay, like it's very complicated, rather I would say. I'll describe that in very easy forms. Hydrogen and some of the metals were considered to be positive valency. Okay, and other non-metals or non-metallic compounds were considered to be your negative valencies. Okay, like for example, suppose copper, that is Cu, is taken +2. Okay, and whereas suppose nitrogen is taken 3-. You can write in both the ways, that is Cu2+, this also you can write N-3. both are correct. Books maybe maximum we use this and and this. Okay, so no need to worry, both of these writings are correct. Now what are these? These are the valencies. Okay, these are the valencies. Now what is the valency? As I gave you such a big definition, some might have got it, some might have not understood it. Like the number of hydrogen atoms which can combine with or displace the group, the atoms of the element to form a compound is called valency. Okay, so this particular definition is very complicated. Let me tell you that in very simpler form. Suppose I am taking the atom, that is the element sodium. Okay, now sodium is losing one electron. Okay, that is, this should be minus, is losing one electron. Okay, so it becomes Na plus, because one positive, as you know, number of electrons and number of protons in an atom are equal, right? So whenever a sodium atom is losing one electron, that means one proton will be more. So that is why it is having a positive charge. So number of that is atoms or number of electrons loosed by a particular atom gives you the a positive valency. And if suppose let's take oxygen, it is losing 2 electrons, or it is gaining 2 electrons, not losing, it is gaining 2 electrons. Okay, that is becoming O2 minus. Okay, because since it is taking 2 electrons more, so that means it was having equal number of protons and electrons. As soon as it is taking 2 more electrons in it, it is becoming O2 minus, that is 2 negative charges coming to it. This is the valency of the oxygen. Okay, now one more thing that I would add to this particular theory is, or to this particular session, is that whenever this oxygen is 2 electrons, it should have the capacity to take up these 2 electrons. It is not that it is not having the capacity of taking 2 electrons and is taking it. No. Obviously it has the need, or it has the capability of taking these 2 electrons, only then it is getting the charge. Now, sodium, it has the capacity of losing 1 electron, so it is becoming Na plus 1. Okay, it is a capacity of how elements or like atoms can lose or gain electrons. Valency basically depends on that. Like suppose magnesium has a capacity of losing 2 electrons. Okay, so it is becoming Mg2 plus or Mg plus 2, whatever you write. Okay, so this is its valency 2. Okay, that is positive 2. So it has a capacity of losing 2 electrons, therefore it is giving Mg2 plus. I hope I am clear with this. That is, each atom has a capacity of gaining particular number of electrons or losing particular number of electrons. If it loses electrons, it gains a positive valency. If it gains electrons, it gives, that is, it shows a negative valency. Right? I hope I am able to clear you about this part. Next comes your radicals. Now, what about radicals? Radicals are generally group of atoms, okay, which shows a particular valency. Group of atoms in a particular element, okay, which shows a particular valency, either positive or negative. Now you might say, what group of atoms means? Group of atoms means, like suppose NH4, okay, this is not ammonia, it is ammonium ions. It is ammonium ions, okay, so NH4 plus. Okay, this is a particular radical which shows a positive valency. Again, 0H, this is the name given as hydroxide. Okay, this is 1 minus. OH minus 1. So this is a group of atoms. See, oxygen is there, hydrogen is there. Okay, and these two both are showing a charge of minus 1. So this is what is radical is. Group of atoms of an element showing a particular valency. here nitrogen is there, hydrogen is there. This two particular group of atoms is showing a valency of +1, positive valency. Okay, I hope I'm very clear with this part. Once more I will repeat, that is whenever, suppose an atom has the capacity of losing electrons, okay, it gains a positive charge, okay, or positive valency. When an atom has a capacity of gaining electrons, it becomes a negative, or it acquires a negative valency. Clear? Examples I've already shown it before. Now, coming to the next part, that is chemical formula. Chemical formula is actually that is a molecule of the substance, or rather you can say 2 to 3 different type of elements combined to form a compound. Now these compounds are also given particular names. Now how do we name these particular chemical compounds? We'll come to it. Suppose, and yes, before I start showing the examples, remember always it is a shorthand representation of a compound. Okay, so whenever we say that, how do we write a compound? Is it both of the elements which are there, both are negative, that is negatively charged, or having negative valencies, or both of them are having positive valency? How is it done? We basically take a metal and a non-metal. Okay, compounds are formed in such a manner, a metal and a non-metal. Now we know that hydrogen is a positive valency, right, +1, but sometimes it does act like a negative valency also. This whole chart of what valencies particular elements are having, these radicals are having, I'll give you in the description box, okay, or within the video only I'll be giving you those screenshots, so you can easily get the idea of it, and you can learn it also from there. These are very important while construction of the chemical formula or chemical compounds. Okay, so coming to it, now suppose we are writing sodium chloride. Okay, sodium is Na, as we know. Okay, and how is the name coming Na? This is a Latin name. Okay, name is natrium. Okay, for sodium, because nitrogen already having N, so sodium is SODIUM. S was already given for sulfur. Okay, so why was it given? SO is also a particular name of a compound. Now Na was given for this sodium just because taking the Latin name. Now sodium and chlorine, sodium is having +1 and chlorine is having -1. Okay, this is a metal and this is a non-metal. Now both of these compounds valencies are interchanged. Okay, it comes to the base. Whenever we write NaCl, it comes to the base 1, 1. This -1 comes here, this +1 comes here, but we never write the charge here. Okay, that is positive or negative. We don't write it here. Neither do we write if both of them are equal, because this is also +1, this is also -1. Okay, only the plus and minus are different. Otherwise, both are having the same values, 1. So we don't write it. We just write NaCl, sodium chloride. Okay, first a metal and then a non-metal. Basically, we do generally in this pattern. Okay, I'll give you some more examples so that it becomes easier for you. Suppose I am writing aluminium chloride. Aluminium is +3. That means it has the capacity of losing 3 electrons from its atoms. Okay, from its outermost shell. And yes, from where does it loses the electrons? It loses the electrons from the outermost shell. Okay, which is the outermost shell? Suppose, I'll come to it in the other chapters also. This is a particular, that is your element. Suppose this to be as oxygen. Okay, I'm writing oxygen here. So oxygen has overall 8 electrons in it. Okay, now the first shell will have 2 electrons and the last shell will have 6 electrons. 1, 2, 3, 4, 5, 6. Okay. In a shell, there is a capacity of either 2 or 8 elements. 2 or 8, sorry, not elements, electrons to be filled up. Okay. Either 2 or 8 electrons to be filled up. Now, here you can already see there are 6 electrons, right? So that means there can be accommodation of another 2 from it. So that means another 2, it can take 2 more electrons. That means its charge will be what? It will gain 2 electrons and will become O2 minus. Similarly for this also. Okay. It has the capacity of losing 3 electrons because 3 electrons are already lying over there. Okay. So if it loses 3 electrons, it will become a stable atom. That is why it loses 3 electrons. Now this, what is stability? These words I will obviously come, not now, afterwards. One day I will just tell about all this. Okay, another class I will tell about all this. For now you just know losing, aluminium has a power to lose 3 electrons and get the power, the valency plus 3. Okay, losing means that is it is a positive valency, and gaining electrons means negative valency. So it has the capacity of having only -1. Now as we said that the 2 valencies will get interchanged, but we will not write the signs over here. So it becomes AlCl3. This one comes here, and AlCl3. This 3 comes down with Cl. So here we will not write this 1. We will just write AlCl3. Okay. This is the particular chemical formula of this particular compound. Okay. Let's take some more examples. Suppose for the radicals there are, and yes, one more thing. Suppose we are using sulfate, sulfite, ite, 8 and ite. Okay, ITE, ATE, ite and 8. What is the difference? This is less number of oxygen, more number of oxygen. Formula SO3 2 minus, formula SO4 2 minus. These are all radicals. Okay, these all are radicals. Sulfate ATE means more number of oxygen, you can see O4. Sulfite, less number of oxygen, you can see O3, O3, O4, O3. Valencies are same for both. Okay, these all are radicals. Now sulfate, suppose I am taking calcium sulfate. No, I'll take something, aluminium sulfate. So aluminium is Al plus 3 and sulfate is SO4 2 minus, right? Sorry. Whenever we take this 2, you know that the 2 valencies will get interchanged. So it will come Al 2 SO4 3. This is a particular formula of the compound. This 2 will come down with aluminium and this 3 of aluminium will come with the radical SO4. That is why we are putting this within the bracket and then writing the 3. That means each of these elements are having number of atoms. Sulfur is having 3 atoms. Oxygen is having 4 into 3, 12. These are all multiplied. Okay? I hope I'm very clear with this part now. If you're having any doubts, please do comment now. We have already so far seen the naming of the elements. We have also seen how we name the chemical compounds, the water radicals, okay, examples of it, and the valencies. I said I'll be providing you with the valency chart as well as the chart of those radicals. Okay. Next, coming to the chemical equations. Now, chemical equations are, as far I said that these are the shorthand form of the chemical change. Shorthand form of the chemical change. Now, there are many type of chemical reactions. Okay, it can be a synthesis reaction, addition reaction, that is displacement reaction, double displacement reaction. Okay, now addition reaction, I'll give you a small example of it. That is A plus B will give you AB. Okay, this is an addition reaction. Means suppose H plus Cl will give you HCl. Okay, so this is what, or rather you can take it like H2 plus O2 will give you H2. Okay, now as it is giving you H2, you can see here this is having 2 here, and here is only 1 oxygen. That means you need to multiply 2 here to get 2 oxygen. Okay, on this side also, and as 4 here hydrogen is becoming 4, so we need to multiply 2 here. Okay, so that it becomes 4 here. Now this is the addition reaction. Okay, this is the addition reaction. Next, coming to synthesis reaction. Synthesis reaction. Synthesis reaction is what? Synthesis reaction is, suppose AB is breaking up to A plus B. Oh, okay, that is just breaking down. So while this taking for example NH3, N2 plus H2. Okay, now it is NH3 is breaking to N2 and H2. This is actually a gas which goes, it is a that is in the air. It is collected by upward displacement of air. Now what is upward displacement of air, what is downward displacement of what, everything I'll comment later, not now. This N2, now see here it is 1 nitrogen, here it is 2 nitrogen, here it is 3 hydrogen, here it is 2 hydrogen. Okay, so I need to multiply this with 2, right? So here nitrogen becomes 2, here also 2, that means balanced, and H3 here it becomes 6, 2 into 3, 6, here it is 2. Let me multiply this with 3, so it becomes 6 over there. So this is a synthesis reaction. Okay, next comes our displacement reaction. Displacement reaction is, suppose AB plus C gives you AC plus B. This is a synthesis reaction. Okay, examples when I will be doing, I will show you by then. This is a displacement reaction. Displacement reaction. And what is double displacement reaction? Double displacement reaction is AB plus CD gives you AD plus BC. This is the double displacement reaction. Okay, that is the elements get interchanged. I'll come to it this right now only, how to do it. Okay, anyway, by that time, let us start with some of the part of, as I said, balancing. What is chemical, how is chemical equations balanced, and why a chemical equation is needed to be balanced. Now, a chemical equation is needed to be balanced because a chemical equation holds, or like these reactions hold, the law of conservation of matter. Now what is law of conservation of matter states? It states that a matter can neither be created nor be destroyed. So whenever we see that, suppose we are taking here for example H plus H2 plus O2, I gave you the reaction that time only, it is giving you H2O, I am multiplying it by 2, here with 2, we are getting this reaction, right? Now you might say that why are we balancing? This is just to maintain the law of conservation of matter, because we have to see that the atoms, number of atoms on the reactant side should be equal to the number of atoms in the product side. This is reactants. What are the reactants here? Hydrogen and oxygen. What is the product here? Water. Okay. Now the atoms of the reactant should be equal to the atoms of the product. That is the main criteria to maintain the law of conservation of matter. So this is very important for us to maintain this. Okay. Now there are many other examples which I can come with. Now ammonia and water, NH3 plus H2O, that is giving you NH4, all like balanced or not. here there is first the thing how to balance the equation. Okay, now you're always going to see the first the metals, whether it is arranged properly or not, that is number of atoms over here, and on the product side whether they are equal or not. Here nitrogen 1, here also 1, right? Here hydrogen, here it is 3 plus 2, 5, here it is 4 plus 1, 5. That means hydrogen is also equal. 1 oxygen, 1 oxygen. That means this equation is already balanced. Okay, this equation is already balanced. Now coming to some other examples, suppose magnesium plus HCl gives you MgCl2 plus H2. You remember I was saying about A plus BC giving you AC plus B displacement reaction. This is one of the displacement reaction. Okay, I said we'll come up with the examples. This is a displacement reaction. I hope it's very clear to you, right? Now, Mg plus HCl gives you MgCl2 plus H2. Now you can see Mg, 1, 1 each. Here hydrogen 1, here it is 2, right? And here chlorine there is 1, here it is 2. That means if I multiply 2 here, then hydrogen also 2, chlorine also will come. Here since it is 2 each, right? So here it is 1 atom, 1, 2, 2. That means it is coming to 5. Here it is 1, 2, 3, 4, 5. That means it is balanced now. I hope I'm clear with this example also. Please try to see the metal and then come to the other elements one by one. Okay, there are some of the you will feel that those are very tough. It needs to be balanced. Slowly and steadily do those, practice more of the equations. I think it will be clear. That is why I've suggested that please try to follow the simplified chemistry book. It gives you many more examples, and almost those type of reactions or balancing only comes for your exam purpose. Okay, next coming to the other part, that is, this was all about your balancing and naming of the giving the valencies or the radicals or naming of the compounds. This was all about it. Now coming to the next part, that is about calculation of molecular weight. Now let's start with the calculation of molecular weight of different compounds. Now before starting that, I will just say or discuss about one particular thing, that is, I think many of you have heard of isotopes, right? Now what are isotopes? These are the elements which have same atomic number but different mass numbers. Like for chlorine, it has the same mass number, that is atomic number, that is 17, but they have two different mass numbers, that is atomic weight. One is 35, one is 37. Okay, now I am going to discuss about relative atomic mass and relative molecular mass. Now what is relative atomic mass? Relative atomic mass is the number of times the atom of an element is heavier than the 1/12 of the atom, that is mass of the atom of carbon. 1/12 the mass of atom of carbon. Okay, and relative molecular mass is the number of times the molecule, that is a mass of the molecule of a substance, is heavier than 1/12 of the mass of the molecule of carbon. This is the difference between relative atomic mass and relative molecular mass. Because this atomic mass and molecular mass, we are going to take it for the calculation purpose. Okay, so let's get started. I think I'm clear, or if else you can I'll just repeat once more, you can listen to it. These definitions will be easily available in the book and all, so you can go through. That is, relative atomic mass is the number of times the atom, that is a mass of an atom of an element, is heavier than the 1/12 of the mass of an atom of carbon. Whereas relative molecular mass will be the number of times the mass of a molecule of a substance is heavier than 1/12 of the mass of the molecule of the carbon. So this is the difference between the two. Okay, so let's continue with the sums here. Let's take for example we will consider the atomic weight first. Okay, take with water, H2O. Okay, let us calculate its molecular weight first. We have to calculate its molecular weight. Now, atomic weight of hydrogen is 1 and oxygen is 16. Okay, now for hydrogen it is 2 into 1 plus 16 into, there is only one atom of oxygen, so into 1. So we are getting 2 plus 16, that is 18. So atomic weight of hydrogen is 1, oxygen is 16. How many atoms are there? 2. So 2 into 1 plus 16 into 1 molecule of oxygen. We get 18. So 18 is the molecular weight of the water. Come to CO2 now, carbon monoxide. Sorry, carbon dioxide. Monoxide, if I am doing this, then it is CO and this is CO2. So carbon atomic weight is 12, oxygen is 16. So for monoxide, let us check the molecular weight. It is 12 plus 16, that is 28. And what is for carbon dioxide? It is 12 plus 16 into 2. Why 16 into 2? Because there are 2 atoms of oxygen. So 12 plus 32 gives you what? 44. So molecular weight of carbon monoxide is 28. Molecular weight of carbon dioxide is 44. Okay. Next, let us calculate for NaOH, sodium hydroxide. Sodium is 23, oxygen is 16, hydrogen is 1. Now as you can see, it is 1 each atom are present. So that means 23 plus 16 plus 1. You are having 23 plus 17, you are having 45. So 40 is the molecular weight of NaOH. Okay. Calculate the molecular weight of H2SO4. This is an acid, right? So hydrogen is 1, S is, that is sulfur is 32, oxygen is 16. Okay. So we will be doing 1 into 2, since hydrogen there are 2, plus sulfur there is 1, 32, plus oxygen there are 4, that means 4 into 16. So 2 plus 32 plus 64. So you are having 34 plus 64, you are having 98. So what is the molecular weight of H2SO4? It is 98. One more example. NH4 whole 2 SO4. Ammonium sulfate. Okay. Now, N we know it is 14, H it is 1, S it is 32, oxygen it is 16, right? Now N, I said each this 2 will be multiplied here, right? So that means 2 into nitrogen is 14, plus this is 4 into 2, that is 8. So 1 into 8 plus sulfur is 32, oxygen is 4 into 16. Okay, so you get 28 plus 8 plus 32 plus 64. So you get here 36 plus 32 plus 64. You get 6, 6, 12, 6, 6, 12, 132. Okay, so 132 is the molecular weight of the particular compound, ammonium sulfate. Okay, so this was all about how to calculate the molecular weight of the different compounds. Now it's directly coming to the that is how to calculate the percentage of the composition, okay, of particular compounds. Now let's get started with, suppose carbon dioxide. I'm just writing the question first so that you can understand the percentage composition of CO2. Okay, now CO2. So first we have to find the molecular weight. Now what is the atomic weight of carbon? We know it is 12, and for oxygen it is 16. So molecular weight of CO2 is what? 12 plus 16 into 2. that is 12 plus 32, it gives you 44. Okay. So we have got this molecular weight of carbon dioxide is 44, right? Now we will come to that is find the composition or the percentage composition of, that is each of the element, once for carbon, once for oxygen. So in 44 gram of carbon dioxide, C carbon has 12 gram, right? Because atomic weight of carbon is 12. Now, so in 100 gram of CO2, C has how much? 12 by 44 into 100. You can calculate and get the percentage. It will come in something in points. 2 6s are 222, 2 3s are 211, that is you're getting 300 by 11. Just let me divide here. So it's coming 27.27%, something like this. Okay, and again in 44 gram of CO2, oxygen has how many gram? See, that is 2 into 16. Oxygen is, that is 32, has 32 gram. So 100 gram of CO2 will have, oxygen will have 32 by 44 into 100. 2 16s are 222, 211, 8. That means 800 by 11. You can again do the division. 11 7s are 77, 330. That is 2, 22, 8. That is coming to 77 again, 30, that is 7 and 2. So you are getting 72.72%. So this is how you calculate the percentage of each of the elements present in the compound. We'll take another example for you to get clear with it. We have that time calculate for NaOH, right? So NaOH, calculating the percentage of each of the elements, composition percentage. So we are having in 40 gram of NaOH, Na has 23 grams. So 100 gram of NaOH will have, sodium will have how much percentage? 23 by 40 into 100. Now this is 20, this is 50, 0, 0 cut. I have got 23 into 5, that is your 15, 115 by 2, that is you are having 50, 7.5%. Okay, next in 40 gram of NaOH, oxygen has 16 gram. So 100 gram of NaOH, oxygen has 16 by 40 into 100. 0, 0 cut, 4 4s, that means 40%. And in 40 gram of NaOH, hydrogen has 1 gram. So 100 gram of NaOH, hydrogen has 1 by 40 into 100. So this is cutting, 2s are 5. So 5 by 2 is your 2.5%. Okay, now you have already got 57.5%, 40% and 2.5%. To verify whether your answer is correct or not, okay, just add these three values. That is, here it is 57.5, 40.0 and 2.5. You are getting 10, this 9, 10 and this is your 100. So the total value is coming to 100. This checks your answer is correct. That is, first you calculate the molecular weight, then taking the molecular weight as per your weight, that is a gram, okay, mass, you calculate each of them like this. Okay, using the unitary method. You obviously know the unitary method, so calculate in this way. If you see these two examples which we have done, I think it will be very easy for you to understand. So this was what was there. That is, first one is calculation of the molecular mass, molecular weight, and then is the percentage calculation of the composition of each of the elements of the compound. So these was what was there in the language of chemistry. I said it was a very simple chapter. Whichever points I said is important, please go through those points. Rest of the thing you need to know, you just read it out. Okay, and for exam purpose also I have said something important, that which is important, which is not. These particular sums or calculations are very important. Before also I said that for the balancing and all, there is one particular book name I have said where you can get many of the points like that. Okay, maximum those chemical balancing come from that book only. Okay, it is very important one. So you can go through this. I think you might have understood whatever I have said. It's very easy chapter. If not, if you have not particularly understood a part or anything like that, please do comment. And if you like this video, if you have understood it nicely, please like, share it so that others can also understand and get the help from you. And obviously subscribe, because we are going to come up with many more subjects. Thank you. Have a good day.